Hello everyone, here we will present our PBL result by title Computer Integrated Manufacturing Miniature MB2. Introduce myself, my name is Ganesha Kusumadewa. I am trusted as a group leader in this PBL progress. And we will explain one part that we have traveled so far. So here we go.
Hello everyone, first of all, please allow me to introduce myself. My name is Taufik Farudin. Here I will explain about the work with done structure in our project. In the work with done structure, there are 3 persons in charge, human research, and 3 persons in charge of the 3 robots in our project, which include arm robot, conveyor, and SCARA robot. Both for those who lead this project or as person in charge is Ganesha Kusumadewa, who is human resource is Endriani, and the 3 robots there are several people in charge. The robot arm consists of 3 people in charge, namely Muhammad Galang Pamungkas as a programmer, Yuni Lovitasari as mechanical, Novita Ramadhani Tias and Revina Angreta as designer. Then the conveyor consists of 4 people in charge, namely Fadilah Ayulansari as electrical, Samuel Haryanto Simatupang, Kelvin, and Muhammad Syahri Ramadan as mechanical. And finally, on SCARA robot, there are 3 people in charge, namely me, Taufik Farudin, and Bagas Abiubiantoro as mechanical, and Rina Dewanti as electrical. That's the work breakdown structure that we made, and basically everyone has their own responsibilities.
I am Yuni Lovitasari Hutajulu. I will presentation a system block diagram, or what is commonly called a flowchart. Before that, what is the flowchart? The flowchart is a diagram that shows the flow of the process contained in a program. As you can see on the screen, is the flowchart of Computer Integrated Manufacturing PBL-MK2010 group. Let's see. The first begin with a terminator symbol that indicates the beginning or end in a program. First, our robot standby or at 0 position. Second, then the sensor will detect the item. Third, if the sensor detects the item, then there is a 2-second delay for the arm robot to pick up the object from the place A to the conveyor. Fourth, if the capacitive proximity sensor reads the data, the conveyor will move to push the object to the place of the object, and SCARA will move the object to the metal place. Then the process is complete. Fifth, if the proximity sensor doesn't read the data, there is a 1-second delay for SCARA to pick up the object from the place of the object, and then SCARA takes the object and move it to the non-metal place. Then the process is complete. This is the flowchart that shows the movement or process of our project. If there is a mistake in a pronunciation, let us both correct each other. Next, we will presenting the electrical distanciation, which will be by my friend. Are welcome to presentation. Thank you.
Hello, my name is Endriani. I will explain the electrical design of the arm robot. The wiring electrical diagram arm robot has 1 input and 1 processor and 4 actuators. 1 input is in the form of photoelectric sensor, which has 3 pins. 2 pins as activator connect to 5-volt power supply, and 1 pin to provide data. The type of photoelectric sensor used is NPN, negative, positive, and negative, where the output of the 3 pins has a 0 volt and GND, which will provide data to Arduino Uno at pin number 6. Arduino Uno is used as program processor from data received by sensor. which will issue output to the actuator. Arduino Uno is powered by 5-volt power supply and GND. The actuator has 4 servo motors consisting of 3 pins. 2 pins as an activator and 1 other pin has a data receiver. Photoelectric gives data to Arduino Uno, then gives data to servo motor for how many degrees the servo motor moves depending on the program made. 4 servo motors have 4 pins to receive data from pin 2, 3, 4, 5 and are activated by 5-volt and GND.
Electrical PWM pulse with modulation to drive 12-volt DC motor using PWM with VCC input and GND. In 1 is on pin 2, in 2 is on pin 3. In 1 and in 2 function to adjust the direction of the motor to go left or right. N1 is on pin 6. N1 works for motor speed controller. A plus A min is a 12-volt DC motor output. Electrical on conveyor. On the conveyor using 3 sensors, which are 2 optical sensor and 1 inductive proximity sensor. Electric conveyor using Arduino 1. Sensor 2 is an optical sensor located at pin 8. Sensor 3 is an optical sensor located on pin 9. Sensor 4 is the inductive proximity sensor at pin 10 with 5 volts input and GND as neutral.
Okay, I will explain the electrical design of the robotic SCARA. The robot SCARA uses a 5 VDC input power supply, 1 Arduino Uno, and 3 5V voltage servo motor, where the power supply is connected to Arduino. Then Arduino will control the movement of each servo motor.
My name is Novita Ramadhan and I'm here to explain about my presentation here. It's about design system. So design system is the manual or the guidelines to make sure the real product or the real project is based on the design, to make sure the clear, flexible, and the fastest way to explain our design. And design system in here, we use AutoCAD software to get into this design mechanic. And then the design itself, it exploded into 4 different parts, which is robot, conveyor, SCARA, and then the table of the project. And my part is SCARA and conveyor. First, I will explain to you about the SCARA. SCARA has the same function as robot, which means pick the materials and replace it into the different area. SCARA itself, it's selective compliance assembly robot arm. And then SCARA has so many different parts, which is first acrylic, which we cutting the acrylic based on the design and based on the measure we measuring. And then the second one is motors DC or servo. And then the third one is the gripper or the gripper. And the last one is base. So we design SCARA based on the real life. We measure it and we took a different scale into AutoCAD software. And then same as conveyor. Conveyor itself, we make sure the conveyor we put the materials in the conveyor first, and then if sensors detected the materials, the conveyor will running, and then the belt will turning, and then the material into the another parts. So the conveyor has so many different parts, which is first is belting, second is aluminum profile, and the body itself, and the sensors. So we designed this based on the real life itself, and we have to put another different scale of this design. So we use AutoCAD itself. It's helped a lot about this design. Based on the concept, we put arm robot first, and then conveyor, and then SCARA, and then the table of the project. If you want more detail about the measure of this design, you can check the attachment or another link that I put in here. And the next part is my partner, Ravina.
My name is Ravina Anggreta with name 421 and 221 and 1050. Robot or open manipulator is a robot model designed to resemble the working of human arm. Robot generally consists of mechanical circuits, etc. and control circuits. The existence of this control allows us to control robot movement as needed. The robot arm has joints like a human hand. The number of joints on the robot arm can technically be referred to as degree of freedom. The minimum system of robot consists at least 4 or 5 servos. First, base servo. The base part rotates right or left. And second, shoulder servo, part of the arm that moves up or down. Third, elbow servo. The elbow part of the robot functions the same as robot arm. Wrist servo. Part of the wrist moves up and down. And the fifth, grip servo. The servo part the function to clamp the workpiece. The robot arm has a length of 12 cm and a width of 1 cm. For the table, part has a length 37 cm and a width of 37 cm multiplied by 2, and a length of 37 cm with 18.5 cm.
Hello everyone, let me introduce myself. I am Ganesha Kusmadewa, the group leader from PBL-2010. Here I am. I will explain the programming part on Arduino is used in general. We use two separate programs because we use two Arduinos. One of which is for the SCARA programs and PWM, and one more for the ARM robot programs. Let's start with the program linked to the GUI, PWM, and SCARA. Here we can see there are several important parts of programming. We start with including servo, which is where to open the library on the servo. Okay, so we can see that. And then we enter the part to put the address on the sensor pin. Here we can see hashtag define pin sensor 1, pin 7, 2 on 8, 3 on 9, and 4 on 10. For SCARA, we provide the pin address and integer value on the SCARA servo, and for PWM2 and for sensor 2, which is then we gave the integer value back to the servo section with the name servo 1, 2, and 3. Okay, then we enter the void setup. We start with the serial code value on the port that we use. Then we continue on the byte E equals 0. then we gave the return address to the motor that will be connected to Arduino. After that, we process to the initial position of the motor that we will set, which aims when the electric current enters the initial position on the robot like we want. So we can see here, that is. And we enter the PWN section, where we will explain that the pin part is the output. Pin mode, 2 output, 3 output, 6 output. And then we enter the void loop. For the section, for the sensor section 1 to 4, we explain that the new one sensor is sensor 1. Then we enter the distribution of the voltage on the PWM or gave which motor direction. We gave the output voltage at in 1, that is a low, or in the form of a voltage of 0. And in 2, in the off a voltage of 5 volt. And after that, we gave the condition to the sensor for what will happen. Sensor 1 reads up to sensor 4. We have 4 conditions here. Little bit left. Okay. Well, here we can see that if sensor 1 reads, it will issue a signal A, which aims at where the Visual Studio will later catch the signal. And if sensor 2 reads, it will issue signal B, and then delay for 2 seconds, which will active the conveyor to the next sensor. And if sensor 3 reads, it will issue a signal C. Then the conveyor turns off, delay for 1 second, then move back, pushing the object to where the object will execute in a way that will the move object to non-metal object. And when sensor 4, as we can see here, sensor 4, and when sensor 4 reads the object, it will issue a signal D, and then turn off the conveyor, delay for 1 second, then push the maximum for 3 seconds, which then the conveyor turns off. Then SCARA will move the object to the metal object. And if not, in all these conditions, then the motor will return to all position or standby. As we can see, this program I programming else. And here for sensor 1, 2, 3, and 4. And this is for new function. We can see here I name it cyclus benda non-metal, which SCARA is moving to benda non-metal. So we can see here void cyclus benda metal. So when the execute sensor, when sensor reads benda non-metal, so SCARA will move to object non-metal. And then we move for robot.
Hello everyone, my name is Assalamulaikum. I will explain the robot program. Hashtag include servo.h, controlling the servo motor, variable declaration, string type variable to store incoming serial data, character type variable that store the first character of data, servo initialization, Object may servo 1, servo 2, servo 3, servo 4, controlling for servo. Servo objects are connected to the pin using the attack function. Early servo is write using function and write. There is a 1 second delay after the servo initial position is set. Main loop, check if there is data available in the serial data. String read code input character to D1. If D1 equals A and sensor 1 low, then enter the cycle function. If no data is available, all sensors are off. Set to false. Cycle defines the movement sequence for the arm robot. Delay to set a certain pause on each movement. Upper arm rises, lowers, base to left, forearm passes. Forearm push and pull. Upper arm down, base to the right. Twisted base. Close, opening and closing the grip. Hashtag 200 program stop execution 200 milliseconds. Servo control function. Return. Use at the end or each function. Right, increase or decrease the servo angle in a loop. Delay for a specific duration.
Okay, my introduce myself. My name is Warahmatullahi, and I will explain about my job in this group. I will make it UI. That I make Visual Studio and Arduino for UI nya. And then this I will in the display Visual Studio I make it for sensor 1, sensor 2, and sensor 3, and then sensor 4, and to counting for metal and non-metal. And this video, the arm robot detects sensor 1 and running until sensor 2 detect and conveyor running, detect sensor 3 and sensor 3 and SCARA running, and then the counting. This the sensor 3, this detect non-metal, so this got non-metal, so sensor 3 skip, and next the sensor 4 detect got non-metal and counting from 5 to 6 and SCARA running and finish. Okay, next I will explain about program Arduino and Visual Studio for my job for UI. And in the pin sensor, I will take pin 7, 8, 9, 10 from sensor 1 until sensor 4. Okay, this the serial communication from Arduino to Visual Studio with baud rate 916. And then okay, this is the communication. If sensor new low and sensor out 1 high, this the principle use principle N. The sensor will output once cause sensor new one low, and after sensor one alt high. This the output only one, and the same for NH, any A, B, C, and D. And then the Visual Studio, the program is this is for serial port, and this is the open for serial port. If open serial port, this appear connected successfully. In display appear connected successfully. In the message box in Visual Studio. This the logic data. If in data A, this panel counter by color, this line color rate for counter 1, counter 2, and counter 3. And B, C, D same. You only change the color for display Visual Studio. In the display, this display. Okay, this the counting metal and non-metal. This is the port, the change port until COM1 until COM10. Okay, if the Arduino in the laptop, they have a port, and any laptop is COM8, COM4. And the start, sensor 1 detect, the flame on sensor 1 is on, but the sensor 2, sensor 3, and sensor 4 is off. And if the sensor 2 detect, sensor lamp for sensor 1 off, sensor 2 on, and sensor 3, sensor 4 off. And sensor 3, yes, the sensor 3 is detect guts metal. If guts metal, sensor 3 detect, the counting will be run from 0 to 1, and then the running conveyor until SCARA, and detect sensor 4 and SCARA running. Okay. Okay, enough from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name Muhammad Syahir Ramadan. My name 4212111057. Okay, we want to tell result about CIM2010. To achieve maximum result, we divide several teams, 4 job decks. For each other are several teams, namely mechanical design, programming, electrical design, mechanical arm robot, conveyor, and SCARA. Documentation, HRD. We share it so you get good result and complete the project in timely manner. We also carry out or analyze the project we make so that existing problems can be resolved, and we also check the input and output components, be it arm robots, conveyor, SCARA, sensor, Arduino, cable, servo motor, power supply, and check back the mechanical goods that we make in order to get the good result. Here we will also explain how to the CIM 2010 goods machine works. The first, all robots are on standby. 2. Optical sensor detects object. 3. If the optical sensor detects an object, there is a 2-second delay for the robotic arm robot to move the object. From place A conveyor, the conveyor will turn on in the optical sensor detect the object is already on the conveyor. If it does not detect any object in the place A, the robot will stand by or be in position 0. 5. If the item detected by proximity reads the data, the conveyor will move to push the object to the place of the object and then move the object to the metal place. 6. If the item is not metal, then proximity does not read the data, so the object will be moved to non-metal. Okay, for the next explanation will be continue my teammates. Thank you.
Hello everyone, my name is Bagas Abibentoro. I will mention some obstacles in our project. 1. Difficulty attending the PBL project creation process because member work shift. 2. Limited time when using PBL room on campus. 3. The presence of damaged material during project testing that increase the cost of expense. 4. Lack of understanding of different somewhere when creating a CIM miniature program. I will mention some solution. 1. Mutual assistance between group member. 2. Make the most of your time on campus. 3. Minimize expense when buying project material. And 4. Learn more in order to understand about miniature CIM software program. Thank you. I will explain about conclusion. In conclusion, industrial automation relies on various components and 3 important. 1 are arm robot, scar robot, and conveyor. Arm robot, also known as articulated robotic arm, are advanced work cells that are highly customizable and capable of delivering rapid response and production. Scar robot, on the other hand, are specifically designed for material handling in industrial process such as assembly, packaging, and pick and place operation. Lastly, conveyor are simple yet efficient equipment used for transportation item from one place to another place, offering fast and effective means of transportation.
First, the project submission deadline is different for the evening class compared to the morning class, as it is quite difficult for evening class students to attend regularly due to overtime work and various shifts. 2. There is flexible time to use the classroom, specifically for the evening class, because sometimes we are unable to work on project-based learning together. Third, the person in charge of the workshop room is sometimes difficult to contact, even though we want to use the room for mechanical work specifically.